Okay, so I was asked to do this one. This problem is actually a chain rule in a chain rule. So the first thing I start is to do that. Now, what I do is I do cheat a little bit. I'm not actually going to do the U substitution twice. So I just move this power out to there. So now that means that this is going to be my U. This is the part where you have to do the double chain rule, but I'm going to cheat and do it without doing that. So I'm going to rewrite my thing. I'm going to replace sine x squared with u, so I have u to the third. I know that derivative is 3u squared du. Multiply by the power, subtract 1, and multiply by the derivative of the inside, which I'm about to compute. So I know the derivative of sine is cosine, and so the derivative of sine x squared is cosine x squared. But this is an x, so I have to take that derivative and put it in the front. That's the second chain rule part. Now, you could do another u substitution. I'm not going to do that. So that's my answer. It's 3 sine x squared squared, and then all of that. And if you want to make it look pretty, you could take this 2x, go move it up there with that 3, and make 6x like that, and then just move this closer, which I'm not going to rewrite it, but that's the idea. Listen, this is a complicated one. There's only one like that on the whole test, but I did ask one where there's a chain inside of a chain. All right, so this is very, very, very similar to the one on the exam. It's almost exactly the same. It's just slightly different. The numbers will change. This is a really, really complicated problem. I would do it last. You have to take the derivative with respect to x of both sides. So I'm going to take the derivative one at a time. So I'm going to take the derivative of e to the 7th, which is 7e7, right? It's e to the u du. Just take the derivative of the power, put it in front. Now, this is where I'm going to run into a problem. This derivative is a product, so I have to use the product rule on it. X to the 4th is the first, sine y is the second. So I'm going to try to just go through it very slowly and very carefully. First, which is x4, derivative second. The derivative of sine y is cosine y, dy dx. I'm just going to write dy to save trouble. Plus second, which is sine y, times derivative of first, which is 4x third. Now I'm going to just clean it up a little bit. I'm going to write it again. This is going to get bad. I'm going to run out of room. So I have x4 cos y dy. Actually, I'm going to drop these parentheses. I don't need them anymore. I would need them if there was a minus here. Let's say this hypothetically, hint, if this was a minus, you would distribute it right now to here and here, and then this would turn into a minus. I'm going to move this in the front. It's still a plus though, because here's a plus. So it's possible that I may have put a minus there, and then you'd have to distribute it. So I don't like this there, so I'm going to move it in the front. I like to do it in alphabetical order. X, Y, Z. So I put X. Oh, I always put X before Y. So that was only the derivative of that. I still have to keep going. So now I need this derivative, and it's got to go all the way over there. So this is chain rule, but you may not recognize that it's the chain rule, but I'm going to show you it's the chain rule. Now I have a -1 there, right? It's -1 u to the 6th, right? Look, there's the u right there. So it's going to be -6 u to the 5th times du. So the derivative of this, the derivative of 3 is 0. The derivative of -2x is -2. So I'm going to be very careful when I do this. I'm going to multiply by the power. I'm going to keep this exactly the same. I'm going to subtract 1 from the power, and then I'm going to multiply by the derivative of inside. That's u. I need the du right here. That derivative is -2. And then again, I'm going to simplify this out. I'm going to do -6 times -2 is plus 12. 3 minus 2x to the 5th, right? So this was product rule, chain rule, chain rule. This, thank God, it's just normal. So derivative of 5y squared is 10y dy dx. And the derivative of cotangent, so I'm going to write that over here. My equal looks bad, it's messing me up. And I'm out of room, so I'm going to do the other one next to it. I'm going to do cotangent down over here because I can't fit it. I'm running out of space. So remember, the derivative of cotangent If you just had cotangent x, it would be negative cosec x, right? Derivative of cotangent is negative cosecant squared. But I already have a negative there, so that's going to make a plus. I also don't have x there. I have 5x, so I need that derivative, which is 5. So the derivative is still cos 5x, right? It's u du. And the sign switched because the derivative of cotan is negative cosecant squared. Oof, my God, that was a lot of fucking work.
Yeah, sorry,
Okay.
Professor. For the first term, 7e to the power of 7x, it's actually a y there. So there's missing a dy
I copied it
for the
wrong.
first term. Yeah,
Oh man, you fucking kidding
okay.
me.
It's okay, it's okay. It's just the
Oh,
first
it's
term.
fine. You know what? Let's see. One, one, two. Oh man. Yeah, it's gonna mess it up if I don't do it. Shit. Thank you. Okay. I won't edit this. I'll leave it the way it was. Had I let and I appreciate you pointing that out. Had I left it that way, I would have ended up at the end of this problem with 4 things on top and 2 on the bottom. And I had said to you that the one on the test is going to have 3 and 3 because I designed it that way. So I screwed this up. I copied the wrong letter here, but it's not a big deal. It's still going to be 7e 7y, right? You take the derivative of the power, put it in the front, but this is going to have a dy dx on it. So now I'm going to end up with 3 of them, which is exactly what I wanted. 1, 2, 3. So I'm going to keep these 2 on this side. Now I'm going to completely cheat after this step. Everything with the dy, I'm going to keep on this side. I want to keep all my dy things together. So I'm going to take that one in a minute and move it over to here where the other ones are. So I'm going to take that and subtract it over to here. So that means all the 3 dy's are on the same side. So that had a dy, that had a dy, that had a dy. Everything that doesn't have a dy, I'm going to put to the other side. So I'm going to subtract this over. That's why this sign is very important. If you have the sign wrong, you're going to move it wrong. So I'm going to subtract that one to that side, and I'm going to subtract that one to that side. So I already had 5 cos squared sitting over there. I'm going to subtract this there. All right, you have to do the opposite. And then you're going to subtract that one over. I'm so glad you pointed that out to me. This answer would have been a disaster. Now I have a dy here, here, here. Factor them out into the front. This is where I can cheat because I have my board and my eraser. I'm going to factor out the dy from here, 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 move it in the front. Then I'm going to take this thing and go write it underneath there. And no fucking way I'm writing it again. So you have all that shit with this underneath it. This is a lot of writing. It's a pain in the ass, and I don't have tremendous space here, but there you go. I relocated it. There's dy, dx, all that crap. So look, 1, 2, 3, 1, 2, 3. Right? You have 3 things. 1, 2, 3. Like, but that's 2 things. No, it's 1 term. Terms are separated by the pluses and minuses, and then 1, 2, 3 things on the bottom. Let's see, did the signs come out right? 1, 2, 3 minuses, a plus, a plus, a plus. Son of a bitch, it did work out like the test. Well, once I fixed it and had it correctly. So again, the one on your test. 3 things upstairs, 3 things downstairs. 3 pluses, 3 minuses. So if you don't get that, if you got 4 minuses and 2 pluses, you effed up somewhere, right? You made a mistake somewhere. So yeah, that was. So again, if you guys, if somehow I copy it wrong or I do something ridiculous and I don't catch it, just feel free to yell out. I mean, it's you have to understand it'll be recorded, but it won't be there forever. It's when the semester's over, I'm going to delete all these because these are just for you guys. These are special. I already have review videos there that I shot on my own. So the first thing, remember, you need an X and a Y, you need an M, and then you need a B. Right, so that's the process I'm going to go through. The first step of the tangent line was to plug the X that I gave you in. Everywhere you see X, you're going to put pi over 2. And you have to do this very, very, very carefully. And I see students screw it up all the time. I don't like the way my 2 looks. There we go. Now, 10 divided by 2 is 5. What about the pi? Stays there. Now, you must cross these 2's out. You have to cross them out, right? It's 2 pi over 2. That's pi. But the sine of pi is 0, right? Remember, you're going to have those values I give them to you. So that means that my y value is 5 pi minus 0, which is 5 pi. That tells me that my original point is going to be pi over 2, 5 pi. Help if I write the correct thing down, 5 pi. So there's my x, there's my y. Right? I plug in my x value, I compute it, I get my y value. Now I have to take my derivative. This is where people screw up, and you got to be very careful. So I'm going to take my derivative. The derivative of 10x, nobody gets this wrong, it's 10. This is where people mess up. This is a chain rule. This is sine u. So it's going to be cosine u du. So the derivative of sine of 2x is cosine 2x. But then I have to take the derivative of 2x, which is 2, and I will put it in the front. Now, the derivative of sine is cosine. So it doesn't switch. The derivative of cosine is negative sine. So then, had this been cosine, this would have switched to a plus, but it's not. So the derivative of sine is cosine, but chain rule. If you forget that 2, it messes up the slope. You're going to get the slope wrong. Once the slope is wrong, then the problem is wrong. So you have to be very, very careful. So step 3 was to find the actual m. Let's write it very precise. The slope m is the derivative evaluated at that number, which is pi over 2. So I'm going to go over here. And there's only one place that I can put x, and that's right here. So just like I did in the beginning, I'm going to cross out these 2's. So I have 10 minus 2 cosine pi. This is by design. So you get 10 minus 2. Now the cosine of pi is equal to -1. Right? This is just a number. The angle is 180. So you get -1. These two negatives make a plus. That means that my m is 12. So I know my m. I know my x. I know my y. So then at this point, you just go and you fill it all in. You have 12x plus b. Right? This is step 4. Write that down. Where the y is, I'm going to put 5 pi. Where the x is, I'm going to put pi over 2. Why am I going to do that? Because that's what x is. Now I'm going to do 12 divided by 2, which is 6. So on that side, I have 6 pi. This side, I have 5 pi. There's my plus b. I'm going to subtract the 6 pi over to this side, and that gives me -1 pi for the b. It always comes out to something cool like that. It works out because everything has pi. So the b ends up with a pi. So you
Professor,
hold on, 12x minus pi. Yeah, what's your question?
yeah, if you put, let's see 1 pi, if you put just the pi, would that be wrong? In the bottom, the b? Yeah. No. Oh, okay.
I just wrote pi.
Okay.
Yes, that's a common question. All right, let me pause it here. So the only good thing about this one is that there's no chain rule in it. I mean, it's a tangent line problem, so you have to do the same thing. You have to get the slope, but they have to give you x and y. I could not tell you x is -1 and expect you to solve for y. You just flat out would not be able to do it. I mean, how could you possibly do that? -1/3. You couldn't do this. Put a -1 here. You could not on your best day solve this for y. You're like, I could collect all these. That's 7 and then subtract 7. It's like, it's impossible. You could not possibly solve this equation for y and come up with -1. There's just no way that's happening. So I have to give you that full point. I give you the x and y. So you actually just jump right into the derivative, which is awesome because this derivative is very easy to take. Derivative of x3 is 3x squared. Derivative of y4 is 4y3 dy. Or if I asked somebody else, they would have told me y squared. You guys give me 1 second. My room's getting too hot. I gotta put my AC on. Derivative of -8x is -8. Derivative of 5y is 5 dy dx. Derivative of 3 is 0. Now it's actually pretty simple. Keep everybody with dy dx. I mean, I'm not writing the dx, but keep the dy dx's on the same side. I really should be writing it. I'll write it at the end. Everybody else has to go. So I have to get rid of that by adding 8. I have to subtract 3x squared. That's exactly how I'm going to write it. So that leaves me 4y3 dy dx plus 5 dy dx. On that side, I have a positive 8, take away 3x squared. Now I'm going to cheat, and I'm going to take my dy, and I'm going to move it into the front. I'm going to factor it out of each of those terms. There was one here and one here. I factored it out. I'm going to divide this under to here. All right, just move it right down to the bottom. So that's what dy dx is. This is dy dx. Now I'm writing it correctly the way I'm supposed to. All right, please do not write y prime here. This is not precise. All right, you're going to be doing derivatives later on. d dt, you have to write dx dt, dv dt. You have to write these things correctly. You can't just say y prime, x prime. You have to write it properly. Derivative of y with respect to x. Now, I need the m. So the m means I take the dy dx and I evaluate it with the numbers -1 and -1. You don't have to write it like that if you don't want to. All I have to do is just plug -1 in for x and plug -1 in for y. Now, if I'm not mistaken, I didn't make this come out to be a fraction. So let's see, you get 8 minus 3 times 1, right? -1 squared is +1, so times 3, still get 3. On the bottom, -1 cubed is -1, and you times that by 4, you get -4. So I made this come out super nice. On the top, you get a 5, and on the bottom, you get 5 take away 4. Be careful. Just because the negative, I will see students put a -1 there. This is not -1. Just because the minus is first doesn't mean you put a minus here. It's 5 take away 4, so it's +1. So that's the m. And then you do the same thing you always do. That's your slope. You're going to put -1 here, -1 here. So let's see, you get 4. So you get y equal 5x plus 4. Now, if I'm not mistaken, I think I had the, I might be wrong about this. I haven't looked at it yet. I'm going to be working on your test tomorrow. I'm pretty sure that I had the slope come out to be a fraction, but this comes out to be a whole number. Like, it's possible that I had the slope come out to something like 5/2, but then x was 4. So then when you get to b, you would cross out the 4 and the fraction of the slope. I think that I did that. I might be wrong. It might be something just like that. But this is the question that's there. Take your derivative with respect to x, isolate the dy's on one side, everything else on the other side, solve for dy dx, plug in the point that I gave you, that gives you the m, and then do the mx plus b. So that one's not super difficult. Okay, so even though this one isn't on the sheet, I have similar ones there. But, you have to know how to handle things like this. Again, you have to recognize it. Well, I'd say you have to recognize it's chain rule, but you really don't have to recognize that it's chain rule because the question is going to say, calculate the following chain rule derivatives using U substitution. This is the wording on the test. Chain rule derivative by using U substitution, which is the method that I taught you, which is the method that all the textbooks use. Some of them use the F and G, which is way complicated and convoluted, but even the textbooks that show that also do the U substitution. So my very first step, as always, is to put it in the correct form. I have to write it as something to a power. So it's a cube root, so the power is 1/3. So this is what I'm taking the derivative of. I immediately identify my U. I am not going to do the du yet. I don't need to do the du yet. I'm going to now replace this thing with u, and I'm going to take my derivative. This is the way that I do it. I replace the u first, then I do the derivative. I need 1/3 of 12, right? Multiply by the power, subtract 1 from the power, and then du, right? The derivative is 1/3 times 12, subtract 1, multiply by du. That's the chain rule part. 1/3 of 12 is 4, right? 12 divided by 3 is 4. 1/3 minus 1. I'm not sure how to do that. That's 3/3. Whoops, 3/3. So that's -2/3. Now I need the du. Very easy. 2x. It's over. Just move that in the front. And then put back your original u. I mean, it looks so simple when I do it. But it's deceptively simple. Rewrite it with a fractional power. Identify your u. Replace the u, take the derivative using the u. So you get a u and a du. I took my derivative now, and I could put everything back. I probably should have kept the u there, but I replaced it. That's what it was. And then I put that u back. 2x goes in the front. Oh, shit, I forgot the x there, didn't I? And none of you said anything. It's okay. I caught it. So I always like to put that in the front. It just doesn't, it looks weird if it's over there at the end. It just looks strange. It looks better if I move it into the front. There was originally something in the front anyway. So I just moved that up there. So that's like the one on the test. I want to do another one that looks like the one on the test. So the good thing about recording this is I don't have to worry about people not copying it because they can just rewind the video or whatever. Let's see. I think I do have one like this. Let me look on the sheet real quick. All right, I'm gonna pause. All right, so this I do have one like this on the test as well. So the thing is, as always, you have to rewrite this. What I see students do is they do this. But that's not how it works. You already know that if you had something like 1 over x5, that you would make x minus 5. But I don't have that. Just pretend I had 1 over ex, and I wanted to move this up. I would write it as e minus x. Okay? But what if it was e2x? Well, same thing. Then it would be e minus 2x. Right? Whatever that power is. So what if it was ex squared? Well, then you move it up, and it would be e negative x squared. So that's what changes. So when you move this up, my board is starting to get nasty. I think it's the eraser. So when I move that up, it's going to be e negative x5 that I'm looking to take the derivative of. So what I want to do is e to the u, because that derivative is e to the u times du. That's what I want to do. So the u is negative x5. The derivative of that is negative 5x4. So now I just have to do that. I already have a 3. I'm going to put the du, right? Let me write it. It's du, eu. Put the du in the front. This is where it goes. And then e to the u. That doesn't change. This, the cool thing about e is no matter what you do with his derivative, he's always in it. Whatever it was. The derivative of e to the u always has e to the u. So you always get what you started with, and then the derivative of that power goes in the front. And then just multiply it. Negative 5 times 3. And then e to the u. You don't have to rewrite this. Don't move it back down. You don't do that. You don't want to make it look back like that again. You can leave it just like this. All right. So again, it's not super difficult. But again, I see students do it wrong. So that's why I did it. All right. So I also have a derivative very similar to this. This one's actually pretty straightforward. This is u to the 7th. It should be bloody obvious. Something to the power. So it's going to look like this. That means that the u is this whole thing right here. That means I need the du. Now, this is a u substitution also. If I asked you to do the derivative of ln, I told you, take this and put it on the bottom. Take his derivative and put it on the top. Right? That's the du over u, even though I already have a du and a u. So now I'm going to simplify that. Right? You have 2 x's on top, 3 on the bottom. When you cross out the x's, you get 3 over x. Okay? So that's that derivative. He goes on the bottom, his derivative goes on the top, I simplify it. All right? Now, I need the derivative of u to the 7. So it's 7u to the 6 du. So it's going to be 7 times this crap that was already there in the beginning to the 6th times the du, which I computed, also using the chain rule. I just cheated. I didn't use the chain rule. I used the chain rule. I just didn't write the chain rule down. And then I'm going to put this in the front. I don't like that there, and I have a 7 and a 3, and I want to combine them together. So I'm going to do 7 and 3, which is 21. And be careful, that x is on the bottom, so I'm going to keep it on the bottom. So there you go. Put the 7 in the front, power changes to 6. When I took that derivative, I got a 3 over x, and I just moved it in the front with that 7. That's where I get the 21 from. So again, not super hard, but people screw it up. People do this. They do 7, 6, and then they take that derivative and put it there. And they put 3x squared over x cubed inside of it. That's the common mistake that I see. Hopefully, if you're watching this, you won't make that mistake. Okay, triple derivative. Before I even do anything, I'm going to rewrite. I don't have to rewrite that. But I do have to rewrite that. I have x on the bottom. I got to move it up as -1 power. Pi 4, nothing to do with that. And I do need to write this. X to the 1/2 power, right? Radical x means 1/2 power. Now, start taking derivatives. You got to do it 3 times, and you have to be very careful. That derivative is 5x4. That derivative is -8. Now, this is chain rule, so be very, very careful. The derivative of sine 3x is cos 3x. Jesus. Derivative of sine 3x is cos 3x times the derivative of 3x. Now here, multiply by the power. -1 times -2 is +2. Subtract 1 from the power, you get -2. Derivative of pi is 0. It's a constant. Over here, I'm going to take half of 12, right? 12 times 1/2 is 6. Subtract 1 from the power, you get -1/2. So that's my first derivative. Now I got to do it again. Second derivative. Multiply by 4, you get 20. Subtract 1, you get 3. This derivative is 0, so it's gone. I'm not even going to write it. I have to do the derivative again. Now I have to be very careful here. Derivative of cosine is negative sine. So I'm going to switch this to a minus. So I have derivative of cosine is negative sine 3x times 3 again, but there's already a 3 there. So now you have a 9 there, right? You had to do the chain rule again. So you get a 3 times the -3. Multiply by the power here. -2 times 2 is -4. Subtract 1 again. -2 minus 1 is -3. Pi was a constant, so it's gone. Here I'm going to multiply. Be careful, it's negative now. -1/2 times 6. That's -3, right? Half is 6. Subtract 1 off the power again. You're going to get -3 over 2. See, a lot of stuff starts to disappear. This would eventually go away if I kept going. This will never go away. This never goes away. This never goes away. Once you get negative powers, they're going to be there forever. So now I multiply it by 3, which gives me 60. Subtract 1 off the power. Now, once again, derivative of sine is cosine. So I'm going to keep that negative there. It's not going to switch. Derivative of sine 3x is cosine 3x times 3. So I have to times it by 3 again. It's continually the chain rule. You're constantly timesing this by 3. Here, once again, multiply -4 and -3. That's +12. Subtract 1 off the power. And then here, one last time. Negative times a negative is positive. So you have 3 times 3 over 2. Don't be a dumbass here. It's 9/2. And you're going to subtract 1 more time. It's going to give you -5 over 2. So that's the third derivative. 1, 2, 3, 4. If there's 4 terms, it's 4 points. If the answer has 5 terms, then it's 5 points, and so forth, right? So obviously going to be very careful there. Okay, so I'm going to do it. So tangent lines, always the same game. First, I need the y value. So I'm going to plug in the x that I was given. I was given x is 0. 3 times 0 is 0. And then I have 11 times 0 plus 5. This works out ridiculously easy. E to the 0 is 1. People screw that up. 11 times 0 is 0. So you end up with 2 plus 5, which is 7. Now I'm going to point out to you that that is already the y-intercept. This is your B. This is B. B is where your graph touches the y-axis. You already finished that part. All I need now is the slope, and I'm just going to write that there. I mean, you shouldn't do that, but I would let you get away with it. So if you take the derivative of this, now this is the hard part because this is a chain rule. So remember, the derivative of e to the u is e to the u. My u is 3x. So I'm going to take the derivative of that power and put it in the front. So I'm going to put a 3 there. But there was already a 2 there. Well, good. They're going to get together and hook up and make 6. Right? So you take the derivative of the power, put it in the front. So that's where the 6 comes from. Derivative of negative 11x is negative 11. Derivative of 5 is 0. Goodbye. So that's my derivative. And again, that's 1 point. 1 point for this. 1 point for this. Now I need my m. I'm going to take my derivative and I'm going to plug in 0. So again, e to the 0. But e to the 0 is 1. So be careful. Watch your signs. That's 6 times 1 minus 11. That's negative 5. So that means my m is negative 5. I want to point out people write this very improperly. People put f of x here. They put x. You're plugging in 0. You can't put x here. You put x here. Look, x, x, 0, 0. People write this wrong all the time, and I've had it corrected. I remember on exam 1 when I was grading them, I had to correct that on like 10 people, maybe even more. Like people were constantly not writing it properly. You got to write things properly at this level. It's calculus. Now, I'm done. You can say, but I have to do mx plus b. No, I don't. My b is right there. And I'm going to prove to you how dumb this is. Watch. Pretend you don't do that. X was 0, right? Look, x is 0, y is 7. If you put 0 here and 7 here, you have fucking b is 7. It's so stupid. There's nothing to do. It's trivial. So whatever you got in that first step is the b, right? Because x is 0, that's it. That's what the y-intercept is, right? The b stands for the y-intercept. So I would let you, if you're savvy enough to understand. Now, if you don't understand what the hell I just said, then do the thing. Put in 0, put in 7, solve for b. But if you understand what I'm saying to you, and you understand how stupid and pointless it is, that it's trivial, and you will always get this thing, then you don't have to plug in the x and y to get the b. You already have the b in step 1. Only now it only works in this only works in this case because of the 0. If x was anything other than 0, you have to solve for b properly, like I did with the 1 in sine and cosine early in the video. All right, so I'm going to pause that.